Hello, welcome back to Ampheto. Last episode we have seen details on electric vehicle four-wheelers. This episode is going to focus on two-wheelers. In two-wheeler EV, there are different categorizations. Electric bicycles, electric motorcycles, e-scooters, and these are the various categories in the two-wheeler segment. In today's session, we are going to understand the different technologies associated with this two-wheeler and the categorization and the various developments.
Let's run through the working of electric bikes. What are electric bicycles? So when someone hears electric bicycle, the first image that comes to the mind is maybe of a scooter or electric motorcycle. But electric bicycles are a different beast. Electric bike motors comes in various power ratings from 200 watts to 1000 watts or more even. The most common type of electric bike's motor is called a hub motor. It is generally integrated into the rear or front wheel, and when engaged, it pulls or pushes the wheel along. Since batteries play a major or a huge part in how electric bikes work, different types of batteries can be understood. One category is a sealed lead acid or lithium category, lithium ion or lithium polymer or lithium manganese, etc. The controller lets you operate the electric assistance on your electric bike and is an important part in how electric bikes work. So we have seen the motor, the battery and the controller. These are the three major components. There are two main styles of controllers. One is a pedal activated controller and throttle based controllers. So we can see a Schwinn electric battery, Schwinn R Runic 29, fitted or mounted on an electric bike.
How does an e-bike work? An e-bike combines your own effort with the power of an electric motor. This motor assists you up to around 25 kilometers per hour. The current for that extra push is supplied by the battery, which is located in the rear carrier. The motor in an e-bike is fitted in the middle of the bike, in the rear wheel or in the front wheel. Smart sensors measure your speed, your pedal force, or your pedal rotation and use this information to provide the appropriate electric assistance. An e-bike is very easy to operate, with controls on the handlebar. This is where you select the level of assistance, for example. There is also a display on your handlebar with readouts for everything, such as how fast you are going or how far you have already ridden.
How do electric motorcycles work? An electric motor and a rechargeable battery propels the vehicle. As we know, the battery stores electric energy, and which is then converted to mechanical to power the electric motor, providing the needed torque. The key components: the battery pack and battery management system. The battery pack stores and supplies electric energy to power the motor. Lithium-ion batteries dominate the market for electric motorcycles due to their high energy to weight ratio and long lifespan. A battery with a larger capacity allows for a longer rides per charging. So this is very important in the market acceptance for a vehicle, because frequent refilling or refueling, recharging will definitely lose the customer's interest and the infrastructure requirement needed to maintain or run the vehicle. So the range is a very critical factor, design factor. So motor and power source. The motor is the heart of the electric scooter. It's a brushless and designed for efficiency and reliability. Next, electronic speed controllers, ESCs. It's like a brain of the scooter. They regulate power distribution and ensure a smooth and safe rides. ESCs also control the speed, acceleration and braking of the scooter. They also communicate with other components to maintain a consistent and safe riding experience. Let's understand another term, regenerative braking system in EV. That enhances its efficiency. When the rider applies the brakes, the regenerative braking system reverses the motor's operation. Instead of using energy, it acts as a generator, converting the kinetic energy back into electrical energies, by which the braking force is being positively utilized. So, design of electric motorcycle. Have a glance at different variants. Electric motorcycle and rider seats, a straight frame. Arc vector is a pictured e-bike, e-motorcycle. Electric scooter, a steps through frame with floor panel. An electric bicycle retains pedals, motor used to assist pedago, a pictured. An e-scooter, we have seen many in the public places or the park and other exhibition centers where for a very short commutation, very safe and short commutation is enabled by e-scooter.
Like EVs and e-bikes, electric scooters are also fast gaining popularity in many cities across the world. Like these other electric transport systems, electric scooters are also battery-powered and particularly work in a very fascinating way. E-scooters allow you to move about your city seamlessly and are efficient for quite a diverse number of terrains. If you're looking to get an electric scooter and you don't understand how it works, then you should absolutely watch this video till the very end. In this video, we've detailed the mechanism behind how an electric scooter functions, and you're surely bound to be intrigued by the simplistic sophistication of this new age technology. Over the past 10 years, the popularity of electric scooters has increased, thanks to developments in technology and material science, advances in ride comfort and convenience, and most importantly, awareness of the risks posed by climate change. The components of an e-scooter include a battery, motor, throttle, brakes, motherboard, and controller. And among these items, the battery and engine are two of an electric scooter's most crucial parts. Now, to comprehend how an e-scooter works, you must first understand the functions of all of these different components. For your scooter to move and take you wherever you want to go, its different components must communicate with one another in a way that gives you control over how it should run and function. The battery. One of the most essential parts of an electric scooter is the battery, which affects how far the scooter can travel on a single charge. The more powerful the battery is, the longer the ride distances on a single charge are, and the better the overall performance of the scooter is. The batteries of e-scooters are typically either a nickel metal hydride battery, a lead-acid battery, or a lithium-ion battery. In many respects, the development of lithium-ion batteries has contributed to the increased popularity of electric scooters and e-bikes. E-scooters are mostly powered by either Samsung or LG lithium-ion batteries, given that they are lightweight, durable, reliable, and long-lasting. An electric scooter's battery is made up of an anode, a cathode, and a porous or void membrane known as a separator. A medium exists between these two terminals through which lithium ions can move. When discharging, lithium ions travel from the anode to the cathode, and vice versa when charging. Electricity with which the scooter is powered is produced by the back and forth movement of lithium ions between the anode and the cathode. To boost the energy storage capacity of current Li-ion batteries, the area between the anode and the cathode has been largely constricted, allowing scooters with this type of battery to travel over a much farther range on a single charge. The energy storage capacity of Li-ion batteries is measured in watt-hours. The higher the watt-hours, the bigger the battery capacity, and the more range the scooter will have. While this is not the only factor affecting the range of an electric scooter, it's about the most important one. Other factors like a rider's weight and road conditions also play huge roles. Motor. An electric scooter's motor is a crucial part. The top speed, climbing ability, load capacity, and to some extent, the range of a scooter are all influenced by its power.
What's the difference of an electric versus gasoline machines? We have already seen this in the case of a four-wheeler. Still, in the context of a two-wheeler, let's run through the differences. Let's do the comparative metrics. Electric and gasoline-powered motorcycles and scooters of the same size and weight are roughly comparable in performance. In August 2013, Road and Track evaluated a high-end electric motorcycle as faster and better handling than any conventionally powered bike. Electric machines have better 0 to 60 acceleration, the initial acceleration, the pickup. Since they develop full torque immediately and even without a clutch, the torque is instantly available on the wheels. Next parameter is range. We have seen about the performance, now it's range. Electric motorcycles and scooters suffer considerable disadvantage in range. We know the fossil fuel, the petrol or diesel filled engines can run kilometers. Kilometers can be run with a single filling or refilling. But the batteries that fit in a motorcycle frame cannot store as much energy as a tank of a gasoline. Anything over 130 miles corresponds to 210 kilometers. On a single charge is considered an exceptionally long range. Consequently, while electric machines excel for city dwellers traveling relatively short distances, on the open road riders experience inhibiting range anxiety. Electric power also trades off range against speed. When the motor is designed for a higher speed, the energy utilization or the discharge rate is obviously going to high, and according to the manufacturer, the long range ZV LRC, the electric scooter, can travel 225 km at 88 km per hour, or in terms of miles, 140 miles can be range when it is being run at 55 miles per hour. But the range drops to about 129 km at a speed of 112 km per hour. So when it is miles, 80 miles for a speed of 70 miles per hour. Maintenance. Electric scooters have very low or almost zero maintenance, since the moving parts and the accessories are very limited. The vibrations are limited. And electric scooters and motorcycles equipped with a regenerative braking typically have longer brake pad life because it utilizes the kinetic energy back. And because of a significant portion of braking duty can be performed with the electric motor instead of the mechanical friction brakes. So when it comes to the cost, the operating cost, the fuel cost, between 1 and 2 cents per mile, depending on electric rates, based on the charging or the electric tariff prevailing in your location. Electric machines enjoy an enormous fuel cost advantage. 3 months and 2,800 kilometer of commuting on an electric motorcycle cost average less than $30 US dollars for electricity. On a BMW gasoline bike, a single trip of 650 kilometer cost nearly the same. In Australia, Utco battery electric motorbike running cost is 88 Australian dollars per 100 kilometer. In India, Ampere electric scooters running cost is at rupees 0.15 per kilometer. Refuel time. Even with special equipment, charging a battery takes significantly longer than filling a gasoline tank. With the maximum number of accessory chargers, it takes over an hour to charge 0 SZF 6.5 kilowatt hour battery kWh battery, that to a 95% capacity. This refuel time also increases with battery capacity. The 0S ZF 13.0, which has a 13 kilowatt hour battery, takes over 2 hours to charge to 95% capacity using the maximum number of accessory. This affects journeys longer than the single charge range of a motorcycle. Next comes the criteria of a noise. We all know a low noise vehicle is always preferred, but noise or a quieter operating vehicle also has some disadvantages. So we know that a pedestrian safety is connected with the horn or a noise a vehicle is generating. An instant reaction or a reflex by which a pedestrian want to slip away from an accident is from the vehicle noise. He or she is able to make out the vehicle is approaching. So the electric vehicles are far quieter than a gasoline powered ones. So an approach may approach a pedestrian who is not watching or unnoticed. So with that risk element, UK is running trials to see if scooters with an artificial noise or warning noise can be safer. Popular mechanics called the comparative quiet of electric motorcycle the greatest difference between them and their gasoline counterparts, and a safety bonus because of their ride can hear danger approaching. Whether a loud motorcycle is safer than a quiet one due to being more noticeable is a matter of dispute. So on a lighter note, we can say at a high speed, the whine of a typical electric motorcycle is said to sound like a spaceship.
Motorcycle engine works in the same way that car engines do. The motorcycle engine consists of a piston, a cylinder block, and a head, which contains the valve train. The pistons move up and down in the cylinder block, driven by explosions of a fuel-air mixture that has been ignited by a spark. Valves open and close to allow the fuel-air mixture to enter the combustion chamber. As the pistons move up and down, they turn a crankshaft, which transforms the piston's motion into rotary motion. The rotational force of the crankshaft is transmitted, via the transmission, to the rear wheel of the motorcycle. The size of the combustion chamber in a motorcycle engine is directly related to its power output. The upper limit is about 1,500 cubic centimeters, cc, while the lower limit is about 50 cc.
Different types of electric bike motors. When it comes to electric bikes, they all use the same basic components: a motor, a battery, and a controller. Let's understand the different types of motors. One is hub motors. Hub drive motors have been around for the longest amount of time. Two types of hub motors. One is a gearless. It's a direct drive on either on the front wheel or a rear wheel. or a geared hub motor which is mounted on another location. So located in the wheel, the motor attaches to the frame of the bike using an axle. The motor being attached to the entire wheel itself spins around the axle, creating the electric assist. Hub drive motors have little to no moving parts, which makes them extremely durable and relatively maintenance free. If damage to the motor happens, they are more budget friendly and more cost effective to replace the whole unit than try to repair it. Since the introduction of the hub drive motors for electric bikes, they have made most of their identity in urban style bikes. Although they can be found in other types of bikes over the last few years, with many manufacturers and a broad range of available motor sizes for power, there are class 1, 2 and 3 hub drive motors available. Class 2 hub drive e-bikes have a thumb throttle for electric assist when you are not pedaling. See the hub motors. Pictures of Orbia Kemen. Hub motors located in either the front or rear wheel, becoming the hub of the wheel itself. So let's understand what's a mid-drive motors. Mid-drive motors are mounted on the frame in the middle of the bike, replacing the bottom bracket. Mid-drive motors uses a series of gears within the motor to generate torque that spins a shaft connected to the chainring. There are many benefits of the system. The motor is able to gear reduction within the motor to reduce the RPMs at the shaft for a higher torque output. This optimizes the performance of the motor and keeps a comfortable pedaling cadence for the rider. Additionally, a mid-drive motor is able to further optimize the efficiency of an electric bike by using the drivetrain gears, whether that be with a derailleur and cassette or an internally geared rear hub. The higher torque output and efficiency have made a mid-drive motor of more preferred or a choice. And which is offering a superior electric assistance on steeper terrain. So mountain bikes are preferring mid-drive motors. The torque sensor on mid-drive e-bikes also provides a more natural pedaling feel, which is important to cycling enthusiasts who are seeking electric assist without losing the pedaling feel of a non-electric bike.